This is the League One event for FTC British Columbia. And in this event, we'll be discussing the League One rankings and the team showcase. We'll be talking about the robots, the teams, and all the progress that the teams have made on the robots thus far. I'm Guy. I'm a FTC alumnus.
I'm Isla. I'm an FTC alumna.
I'm Eric.
I'm Ryan. Sorry, I'm Ryan, and I'm volunteer.
I'm Kath. I'm an FTC alumnus, and I also do refereeing and inspections this year. Derek, do you want to go?
I'm Eric, and I'm a non-FTC alumnus. And I'd like to give thanks to our sponsors, Fortis BC, Energy at Work.
We would like to acknowledge the communities and nations on whose territories we work, live, and play. For where I am, that's the Wasanic, the Lekwungen, and the Willamette peoples of the Coast Salish nations. Your land acknowledgement may be different depending on where you are. I would recommend that you check out nativeland.ca and add yours to the chat on YouTube. Now let's learn more about First Tech Challenge.
First Tech Challenge challenges kids ages 12 to 18 to program, design, build, and compete with robots.
Once you get the challenge, you figure out your game plan.
You build a robot so that you can complete many challenges.
Teams use a reusable kit to program robots in a variety of coding languages.
Every year you also learn more and more about coding, so then your code's gonna get better and better.
Personally, I do not learn hearing about it, but hands-on is just go into it. Instead of saying, oh, I know how to build this robot, I can say, I built this robot.
In First Tech Challenge, students are developing a broad range of skills.
Manufacturing, hardware, troubleshooting, but there's also a lot of things that you learn that you wouldn't necessarily think about. People skills.
Problem-solving skills.
Helping one another, helping other teams.
The program draws so many students that come in who just want to do the marketing, who just want to do fundraising.
You need to do fundraising because you need to buy kits and parts and everything you need for the year.
And that's a great thing that the kids learn very early on.
The model of FIRST has provided incredible opportunities for the students to interact with professionals.
Whenever I ask my mentors a question, they always flip the question around and ask, where would you find the answer to that question if I weren't here? They slowly built my confidence up so much more to a point where we weren't asking them questions. We were just going.
Each team has to compete at a local event, win awards at the local event, and then they're able to move on to the first championship.
You walk into the room and there's that smell. The smell of robots.
There's different languages, different culture. It's just the best thing ever.
I think it's incredibly important for youth to see careers in science and engineering as a possibility for them.
High school participants have access to over $80 million in scholarships from colleges, universities, and technical programs. First Tech Challenge is one of 4 engaging FIRST programs.
First in one word, wow.
Fun!
First is inspiration.
First is amazing.
First is hope.
And now on to this year's game. It's called Ultimate Goal this year.
A team consists of up to 2 driver operators, a coach, a human player, and a robot. The robot must be built from materials specified in the game manual and fit within an 18-inch sizing tool, but may expand after the match begins. Each match is played with 4 randomly selected teams, 2 per alliance. Each alliance is allowed only 1 human player. Your opponents for one match may be your partners for another. The game is played on a 12-foot square playing field with a foam tile floor and 1-foot-high walls. 5 unique navigation images are located around the field perimeter. At one end are 2 tower goals. each containing 3 Alliance-specific goals with return racks. Between the 2 tower goals are 3 red and 3 blue power shot targets. There are 2 red and 2 blue taped start lines, and 3 red and 3 blue target zone goals. And a white launch line divides the field. Outside of the field walls are the 2 Alliance stations and 2 human player stations. The primary game element is a ring, approximately 5 inches in diameter and 3/4 of an inch thick. A match is played with 20 rings. There are 2 red and 2 blue wobble goals. These can have rings scored onto them and can be moved for additional scoring. Before each match, teams place their robots on the field, touching the front wall and over one of their Alliance's starting lines. Each robot must be touching or be in possession of a wobble goal. A robot may possess or touch up to 3 rings. After the robots are in position, field personnel will randomize the starter stacks into one of 3 configurations. This determines which target zone goal is active in the autonomous period. 0, 1, or 4 rings correspond to target zone goals A, B, or C, respectively. Unused rings are stored in the human player stations to be deployed to the field at the start of the driver-controlled period. The players and field are ready. Each match begins with a 30-second autonomous period. During this period, there are a number of ways for teams to score using only pre-programmed instructions and sensor inputs. Delivering a wobble goal to the correct target zone earns the Alliance 15 points. A robot parked over the launch line earns 5 points. Each ring launched or placed into the low goal earns 3 points. A ring launched into the mid goal earns 6 points, and launching into the high goal earns 12 points. Robots earn 15 points for each power shot target knocked down. Robots must be completely within the launch zone to launch rings into the mid goal, high goal, or power shot targets. Following the autonomous period is the 2-minute driver-controlled period. During the driver-controlled period, human players are expected to return rings to the playing field, as well as reset power shot targets. Each ring launched or placed into the low goal earns 2 points. A ring launched into the mid goal earns 4 points. However, rings launched into the opposing alliance's goal earn points for their alliance. A ring launched into the high goal earns 6 points. The last 30 seconds of the driver-controlled period is the end game. During this time, robots may continue scoring rings, but there are also ways to earn bonus points. Each knocked down power shot target earns 15 points. Returning a wobble goal to the start line earns 5 points. Each ring fully supported by the wobble goal earns 5 points. If a robot lifts a wobble goal over the front wall into the drop zone, its alliance earns 20 points. There are many ways to score in Ultimate Goal, but there are also rules that, if not followed, will deduct points from your alliance. For example, a robot may not block another for an extended period. A robot may not possess more than 3 rings at a time. A robot may not launch rings over the side or front perimeter walls. A robot may not intentionally tip another robot at any time. This has been a brief summary of the Ultimate Goal game. For complete rules, please read the entire game manual and check the Q&A forum. For more information on our remote season, including gameplay and field requirements, please make sure to visit our game and season webpage for the full library of remote event documentation. And always remember the most important rule of First Tech Challenge: gracious professionalism. Good luck, teams, and have a great season.
Hello, my name is Christine Nichols, and I am the First Tech Challenge partner for British Columbia. Our first league event has just wrapped up, and I know that all of our teams are dealing with a lot of unusual challenges this year, whether they're finding it almost impossible to meet or whether it's just they have to follow all kinds of extra rules so that everyone can stay safe. So for those teams who were actually able to get their robots working and submit scores this week, I am in awe of what you have accomplished. It has been a year like no other, and I'm delighted to actually see all the videos of all the cool things the robots are doing. First off, I would like to say a special thank you to two of our schools, St. Margaret's in Victoria and St. Patrick's in Vancouver. Both of these teams offered to host open fields for those teams who don't have their own full field setup available for competing for the remote event. Unfortunately, we weren't able to use St. Patrick's, but on Saturday, St. Margaret's did host the community teams here in Victoria. And so a special thank you to the two St. Margaret's teams for being willing to share their fields and the space at their school. I know the teams who were there really appreciated the opportunity to have a much nicer setup than they would have had otherwise. And if any of the other schools are interested in hosting scrimmages or other events, please let me know. Depending on whatever the current health rules are in your area, it would be really exciting to see matches with 4 teams and 4 robots playing at the same time. So hopefully we'll be able to get some of those events going soon. And of course, everybody is asking what comes next. So it's not exactly clear what our schedule and what our events are going to look like this year. We are going to be finalizing the events as we get closer to them. But what I can give you is dates. So we are expecting League 2 to wrap up on January 16th and 17th. League 3 would wrap up March 13th and 14th. And the BC Championships will be held on May 1st and 2nd. And so we are optimistic that some of these events will have live competition components. But of course, it's all going to depend on what's happening in BC as we get closer to those dates. And for now, I'm going to send things back to our game commentators so that they can get the team showcase started. Good luck this season.
Okay, so for our first team, for the team showcase, we have team 18191 from St. Patrick's. They're named Incline Robotics, and this is actually their first competition ever.
Hi everyone, we are the St. Patrick's Incline Robotics team, and we are from Vancouver, BC. So we are in grade 10, and this is actually our first robotics competition, and we had 3 weeks to prepare. However, we are proud of what we have accomplished.
Initially, we had a lot of problems, so we designed a 3D claw to begin with, and that didn't work. Then we designed a wobble picker-upper, and that did not work also. But today, we were able to do a very good competition.
Yeah, so a few of the things that we did well on is we actually got a way to place the rings on the wobble, and we are very proud of that. And so overall, we are excited to continue in this competition. Yeah.
St. Patrick's Robotics, we are inclined to win.
Let's go Celtics!
For this team, the autonomous program scores points by parking on the launch line and moving the wobble goals around. And so it did a great job of doing that. They also held 3 rings throughout autonomous so they could score later on during driver control period. And interestingly enough, we could see a curious wooden panel on the back of the robot, which is definitely cut in a way that it's intended for something, but we didn't get to see what exactly. So hopefully we'll get to see that in League 2.
So next up, we have team 13459 Mark. They're from St. Margaret's in Victoria, and they've sent us a video of their autonomous program. That was a great and nice and simple autonomous program. Sometimes those are the best. Just work every time they're supposed to. I wonder if they're able, though, to repurpose that arm mechanism and throw rings during the driver control period. That might be interesting to see. It also seems like they've got a good amount of maneuverability on that robot, and maybe they can push the wobble goals around during the driver control period as well and get that working. We're excited to see what they develop and how their driver control strategy changes in the upcoming events.
So next, this is Forces Unknown, team 16-67. They're a community team from Vancouver, and this is their 3rd year competing in FTC. So this video is really going to show this team's development process for League 1. And what's nice about it is they actually start from drawings that will come up soon. And then they'll take these drawings and we'll be moving to actual CAD designs. And we'll be seeing very specific and comprehensive showcases of basically what their mechanisms are going to look like. Now the design and actual building process, which obviously there's going to be a lot of adjustments made. I like how the wheels turn green all of a sudden. That's a nice change. Yeah. And so here we can see what everyone recognizes to be a staple of robot building, which is to say you have the final robot and then you have adjustments afterwards. But here it is, the robot's moving quite well, and you can see with the Mecanum wheel drive, it can turn and move and sort of strafe at the same time. And up soon, we'll actually be able to see the ring shooter in action. There we go. Okay. In addition to the shooter, there's actually, if you missed this, there's a wobble goal grabber. Unfortunately, we didn't get to quite see it in action, but hopefully we'll be able to see it for League 2. Okay.
And so the next team we've got is Dudley's Troopers. They're from St. Margaret's School in Victoria, BC. The Dudley's Troopers are still working on their robot, and they're making good progress. And we'll be excited to see them compete in more matches at League 2 in January.
Okay, so for many of you know, but for those of you who don't, there are going to be many awards given out at the FTC BC Championship later on in the season. And so we thought this would be a good time to stop, talk about what each award is about and what are some of the requirements for each one. So first up, Inspire Award, probably the most prestigious. This judged award is given to the team that best embodies the challenge aspect of the First Tech Challenge program. So this means that your robot design is creative and innovative. The entire engineering portfolio must be high quality and well organized. And the team shows respect and gracious professionalism to everyone they meet. Then we have the Think Award. And this award is about the engineering portfolio and the engineering notebook. And it's given to the team that best reflects the journey the team took as they experienced the engineering design process during the build season. So that means the engineering portfolio must include engineering content, such as the robot's underlying mathematics and strategy, and also capture the summary of the current status of the team and their robot design. After that, we have the Connect Award. The Connect Award is basically about reaching out to the local STEM community and talking to mentors and industry professionals, and really just connecting with people who've done robotics in real life. The Collins Aerospace Innovate Award celebrates a team that thinks outside the box and has the ingenuity, creativity, and inventiveness to make their designs come to life. So that means your robot or some part of your robot must be creative, elegant, and unique. There's also the Control Award. It celebrates a team that uses sensors and software to improve a robot's performance in the field. For this award, you must submit the Control Award submission form, and each of the control components must enhance the functionality of the robot. And just an extra tip, I feel like things that include computer vision and robot intelligence would probably work very well in the judge's eyes. But in general, anything that what makes your robot do better would be good for the Control Award. There's the Motivate Award. This celebrates a team that represents the general enthusiasm for the overall philosophy of FIRST and what it means to be an FTC team. And this means your engineering portfolio must include a team organization plan, such as team identity, outreach, finances. And above all, it means your team is respectful and gracious and shows gracious professionalism to everyone they meet. And finally, we have the Design Award. This judged award recognizes design elements of the robot that are both functional and aesthetic. You must submit an engineering portfolio for this award, and it should show that your robot was built with industry design principles, balancing form and function. And in general, if you're going to remember anything about this slide, remember that you must submit an engineering portfolio to be eligible for these awards.
Right, so connecting with other teams. As you all know, right now, we're pretty much isolated. We're all stuck at home. But it's really good to still be able to talk to other teams in the area and exchange ideas, see how everyone's doing, because robotics, and especially First Tech Challenge, is not an isolated event by any means. It's designed to be done with other people. So in order to help you, to help facilitate this communication, we encourage you to start a team website. This can include information about your robot, the design process, community outreach that you might be doing or might have done. It's also great to start a team email account, something that has a distinctive name and number so that people know exactly who it is they're going to be talking to. This allows your team to communicate more professionally as well once you start looking for more sponsors and looking for more events. Social media, some of you already are, but being active on platforms such as Twitter and Instagram is really going to let you communicate with other teams around the world who are all participating in First Tech Challenge. And as well, if you didn't already know, there is an FTC BC Discord. So the server link I'm not exactly sure where it can be found, but it is somewhere. And that would be a great thing to join. So this is a good time for your programmers to maybe learn a little bit of HTML, CSS, maybe let your students who might be more interested in design find something pretty and whip together a team website. Because if you can share a website and you can share an email address, it's a lot more fun to be able to go and talk to other teams, see what they're all up to.
So we keep talking about this engineering notebook and engineering portfolio. The engineering notebook is one way that First Tech Challenge recognizes the engineering design process, the journey that the team takes in the phases of creating their robot. The engineering notebook also can include business plans, outreach goals, design. We already talked about the robot design, development, as well as the team's insight in what it means to be a First Tech Challenge team. You might also, this year, you might want to include if you're, how your team's adapting to COVID, what strategies they're using to, still make do with what time they've got. Now the engineering portfolio, this is new this year, and it's required in order to be considered for any of the judged awards, and it should gather information from the engineering notebook. The engineering portfolio also must not exceed 15 pages, and it's going to be a new thing this year. The requirements are covered in Game Manual Part 1 if you need to take a look at that. I highly recommend you do. And just to mention in the YouTube chat, just letting you know that we will be letting everyone see the scores at the very end. But we just thought we had a chance to showcase all the teams first. So let's continue on with the showcase.
Team 16195 is the Guild of Builders. They're in their third year with a 6-member community team. We're hoping that thing that, not quite yet. We're hoping that thing that looks like a cannon turret is actually part of the wobble goal being carried. Interesting features of the robot include Omni wheels for greater maneuverability. They have a shooter that's capable of scoring the lower goal, possibly higher. Floor collection of rings to feed the shooter. As you can see, their wiring is well done and organized. It's one dense package of powerful machinery.
All right, so next up we have team 18502 from St. Patrick's School. They are Marlowe's Machinery.
We are the Celtics from St. Patrick's Regional Secondary. This is our first, and it's our first time being together as a team to build an awesome robot. We are in our grade 12 year, and hopefully we will do our best, work together to build something awesome. We are Marlowe's Machinery, and don't forget to follow us on Instagram and on YouTube. Thanks, guys. Yeah, you got it.
So definitely a great example of having platforms for other teams to communicate with you on. You'll notice that this robot has mechano wheels, allowing it to maneuver easily around the field, as well as spin on the spot, and an arm, which is currently holding a wobble goal. Hopefully we'll see it score that once they start the match. This design may look relatively simplistic, but I would love to remind you that it is sometimes the most simple designs that are the most reliable and therefore easy to maintain and will work every single time. So never knock the reliable, simple designs. And there it's going. Is it going to score the wobble goal? Yes. You may even call that a smashing success.
$18,589 is St. Pat Celtic Silverfish. another first-year team from St. Patrick's with 11 members. They're using Mecanum wheels. They have a shooter which is optimized for the low goal. This team went in search of motors because they found their earlier motors weren't fast enough. This team has discovered the iterative design process.
Hi, my name is Aldrich and I'm a builder.
I'm Ibrahim and I'm also a builder.
Oh yeah, same.
I'm Chris, I'm a builder and a controller.
Hi, I'm Olivia, I'm the programmer.
I'm Natalie and I do documentation and sometimes control.
Hi, I'm Alicia and I'm also a programmer.
Hello, I'm Andrea and my role is a builder.
Hi, I'm Tia and I help with outreach.
And we are the Celtic Silverfish. So this is our first time participating in the first tech challenge, and we've learned how tedious it actually is to build a robot, but how rewarding it is to finish it and see it in action.
For example, when we first got the robot, to move and build the shooting mechanism, everyone was so excited to see it work.
However, it didn't always go smoothly. Some of the challenges we faced were building and making the shooting mechanism.
Originally, all of our motors were way too slow to shoot the rings. So, to overcome these challenges, we bought a faster spinning motor, and finally, we were able to shoot something.
For our next challenge, we hope to be more organized and prepared. We wish the best of luck to the other teams. Sorry, I didn't know you're gonna pass it to Heather. You're gonna pass it to my hands are shaking.
All right, so next up we have team 16353, Reynolds Robotics from Reynolds High School. They have 5 team members, and this is their second year as a team. Let's see what they've sent us.
3, 2, 1.
That was one really fast autonomous and a couple of great ways to reuse mechanisms to be able to score the wobble goals. I really like how they can have one as a preload and still use the same mechanism to be able to score some later on in the game. Great job, guys.
"3491" is Team Fix-It, a team that dates back to 2009. As you'll see, this team's spirit is flying off the screen.
In case you didn't catch it, our robot's name is Beyonce. She's a Mecanum-based robot chained at a 2-to-1 ratio. She has a flywheel shooter and a linear slide wobble grabber. The reason why Fix-It chose the name Beyonce was because we wanted to have a robot name that relates to the game. There's a pretty famous song that a lot of you may have heard of that's called Single Ladies Put a Ring on It that inspired us. The name Beyonce also gives the team a reason to bedazzle the robot. A lot of us have had to make some adjustments this season, since we are living in a pandemic. Fix-It is fairly lucky that we have a small team to make this transition a little easier. So far for us, there has been minimal in-person meeting time for building and driver practice, while most things such as design, strategy, outreach, and engineering connections have been moved online. We've made the most of it, and continued on with meeting regularly and connecting. just virtually. Some of the online activities that we've enjoyed were group calls for just chatting and playing Scriblio, team meetings, gaming, and playing D&D.
So I'd love to see what type of range their shooter gets when there isn't a goal in the way, because it was shooting from all the way at the back end of the yard.
Okay, so as many of you know, every season and every year of FTC, the game changes. And with each new game, new strategies arise, and it can be sometimes difficult to really navigate around these new elements that you might be facing. So we figured now would be a good time to ask an expert, in this case, Kath, some questions about how to deal with these new game elements and where they might have showed up in the past in FTC. So one example of this would be the rings that we're trying to shoot into the goals of different heights. And so, Kath, how long has it been since there were launched elements like the rings in an FTC game?
Well, technically Robotics was the last year that had launched game elements. Most teams were encouraged to place the scoring elements in the ladder that year. Thinking back further, you're probably looking at Velocity Vortex, which was 2016, 2017. I'm actually really excited to see how the teams deal with the foam rings because they're more flexible. Because in most previous seasons, the game elements are made out of hard plastic. So that softer foam material is going to be interesting to see how they handle and make sure that they don't damage them.
Right. And these rings, they're also being used for setting up before the autonomous period. So where they randomize if there's going to be 4 rings, 1 ring, or no rings, and that will change the autonomous period. So in the past, when has FTC used these randomized elements?
Well, randomization has been around since 2015. And that year there was an element that could change colors. And depending on where the color was, your alliance would have to place something in that object. But this year, the randomization, as you were mentioning, is the starter stacks. And depending on the randomization, it's either 0, 1, or 4 rings that are placed in starter stack. And that corresponds to which target zone the team need to place the wobble goal in to get points during the autonomous period. Teams should remember that when they're running their matches, they should place the robot on the field, select their autonomous program, get it fully set up for the start of autonomous period, and then use the scoring system to randomize the starter stack. And once that starter stack's in place, then the drive team, all they have to do is just press start on the autonomous program and start the match.
And for those of us who haven't been developing, the software for these robots recently, we might see the navigation images from the game video. What exactly are they supposed to be used for?
Well, the navigation images can be useful during the autonomous period to know where the robot is around the field. Teams can use TensorFlow and Vuforia when programming in either blocks or on Java and get the camera to do image processing analysis and, make decisions based on that. I think also some teams are making use of the image analysis to look at the starter stack and figure out how many rings are in the stack.
Yeah, that especially I feel like would be good for controller word documentation. So in the past, the endgame has always been critical for scoring points. We all know this. But for this particular endgame, what should teams remember?
Well, the big piece about endgame is always that teams cannot start endgame tasks before the endgame period. And in the case of the wobble goals, they need to be outside of the launch zone or in a target zone at the start of endgame to be eligible to score. Similar to how the rings this year have to touch the field floor before they can be scored again. So wobble goals can get 5 points for being returned to the start line, or they can get up to 20 points if they're placed in the drop zone, which is outside the playing field perimeter on the audience side. Also, rings can be scored on the wobble goal, but those rings can't be on the wobble goal until endgame has started. The other thing that can happen during endgame, there's so much this year that can happen during endgame. is that the human player needs to remember to reset the power shot targets so the robot can hit those targets and move them into the backward scoring position during the end game period.
Wow. Okay. Obviously, there's way more we can talk about, but upcoming is the last 5 teams, the top 5 teams actually that have, in terms of number of points scored. So we'll continue on to those, but first, teams should always remember gracious professionalism, and you should be having fun doing these matches. Okay. Now we can move on to the next 5 teams.
All right, so the team that is 5th in the rankings is team 18840, Reynolds Robotics. And they're another rookie team. They have 3 members, so let's watch the video. I like their use of mecanum wheels to be able to move around on the field and spin on a dime. And that is definitely one of the most sophisticated robot arms we've seen in this season. I like how they're able to use it to pick up and pour over the side barriers. That's a very clever design. I look forward to seeing if in the future they decide to deal with the rings in some way to build a shooter or to find some way of scoring those, maybe even with the same mechanism, if they can find a clever way of doing that.
Autonomous Innovative Mechanisms, or AIM for short, or AIM Robotics, is a community team from Coquitlam, and this is their 2nd season competing. So what we're going to be seeing in this video is a fairly good autonomous program that senses the randomized stout stack of rings and correctly navigates to the wobble goal to the correct target zone based off of the randomized stout stack of rings. So here it's placing that in target zone C, I believe.
It's target zone B, but very close.
Oh, all right. One off. Yeah, and you can see that they have fairly good control of the wobble goals, and they will actually be using that also for endgame to push them out into the drop zone. Okay, that's 2 wobble goals dropped. So that's a pretty successful endgame.
So team 6031 is Parabellum, a returning team with 7 members. Their robot uses a single flywheel design and has a nice device to collect rings from the floor. This team has made an impressive use of CAD for prototyping and design, very helpful when your team can't meet in person. Let's play their video.
Hi, we're Team 16031, Parabellum. We're a returning team this year, but with all the unprecedented changes, it feels like we're rookies all over again.
One of the things we have done to adapt to these new circumstances is to move our weekly meetings online. The intention behind this is to reduce our in-person physical meetings as much as possible. This means that a lot of our work has been done virtually and independently. As a result, we have begun to rely heavily on designing and prototyping through CAD software such as Tinkercad and Fusion 360.
The first of the 3 technical highlights we want to showcase in this video is our shooter. This is our same-side shooter that uses a motor-driven wheel called a flywheel in the center of a curved pipe to propel the rings.
So for League 1, we're going to be preloading 3 rings into our pedestal holder. Then we're going to have another servo-powered arm that will push the rings into the flywheel, launching them towards the high goal.
Secondly, we wanted to up our navigation game by using odometers, which track the relative position of the robot on the field. To do this, we needed to design a new odometry holder, which accommodates a small wheel and a chunky rev encoder. This is to be mounted on the underside of the chassis and be able to absorb shock as we drive around.
And to finish, we have our ring intake. Our current prototypes are using rubber rollers like those found on your typical household Roombas to move rings up to the shooter. These rollers are connected to each other by a sprocket and chain and are powered by a single motor. At least that's the idea.
This preseason, we've had a lot of opportunity to experiment, but not all of our ideas became a reality, so we're working hard to achieve our goals, and we hope you anticipate our future games.
And now we've unfortunately reached the saddest part of this video, the end.
So next up, we've got our second place team, 15013 Friction from St. Michael's University, and this is their 3rd season competing. So you can see here that they had a really simple autonomous program that just drive forward to the target line and got points. And now they're doing a great job of picking up rings and scoring them in the logo. And I think what we're going to see now is they're picking up the bubble goals and getting them scored over the field. That's actually a really good use of mechanisms, getting to have the same mechanism be used for different tasks on the field. That's a often hard thing to design in. Got some photos here of their team process in fixing
And now the team that is so far in first place is Team 16205, Lightning Bots. This is their second year competing. They're a homeschool team from Coquitlam.
Hi, my name is Jerry Ma. I'm one of the main builders of the team. Now, in the robot match, I don't do a lot, but off match, I'm the one who checks the robot.
Hi, I'm Charles. I'm one of the programmers for the team, and I mainly program autonomous. I'm also the human player and the tool manager for the team.
Hi, I'm Henry. I'm one of the main programmers for the team. I coded our driver control program, and I'm also a secondary driver.
Hello, I'm Bruce. I'm the main driver and the builder of the team. I designed the intake and the shooting system.
Wow, that's a really cool shooting mechanism. how they can adjust their distance from the goal in order to adjust which one they're trying to score into. And I think that arm on the side is going to be used for the wobble goals, which is pretty cool. Very reliable mechanism. That's impressive. That takes a lot of time to do. Yep, and they picked up a wobble goal. Maybe we'll see them score before the video is finished. Oh, they can adjust where they're shooting while they're going. That is very impressive. And that is the last of our showcase. And now we're going to go on to the rankings.
Here are the rankings. If you're not sure what the columns mean, look in Chapter 5 of the Game Manual, Part 1. You can find the match scores at FTC events, firstinspires.org.
Thank you to all of our teams for submitting their videos and photos. It really wouldn't be a team showcase without you, and we really look forward to seeing you at League 2. If you want to reach out to us at any point, you can contact us at firstroboticsvc.org. And for the match scores, as previously said by Eric, you can find them at ftc-events.firstinspires.org. And happy pandemic, everyone.